So hey everybody, this is Mr. Bells here. This video is for my geometry class. This is lesson 2-4 and it's on algebraic proofs. So again, as we've talked about, we're going to get more and more details into these things called proof, and we wanted to start with something that I know that you guys know how to do, and that's algebra based stuff. And as we talked about these hypotheses and conclusions and these statements and reasons, we're going to say something's true, and then I just simply need you to tell me why it's true. So like, for instance, I have an orange right here. I'm going to take the orange and I'm going to release it, and it falls to the ground. So the statement is, if you drop an orange, it will fall down. And well, what's the reasoning? Well, the reasoning, of course, is gravity's effect on Earth pulls objects towards it. So all we're doing is trying to justify it. But we're going to need to be really specific about our justifications. So like if I said these two lines right here are perpendicular, why do they form a right angle? We need to be able to state exactly why they form a right angle. Or if I had two lines like this that happen to cross, why are these angles over here and these angles over here both congruent? And we're going to need specific justifications for those. And as we go, we're going to build and build and build this huge library of knowledge, but we got to be specific on why it works. Okay? So here we go. Here's some basics for it. We're going to start with this. So we start off with this expression right here. And again, these are going to be algebraic proofs. And I'm just going to give you some possible justifications for why we're able to do what we do. So write given equation. So we wrote this out, and we're probably not even going to use all these things. We're just going to say it's given to us. So we're going to be given an equation. So now the question is, what did I do mathematically to go from this line to this line? And then I need to write that justification right there. So I hope you can see that right here, the only thing different, the 4 becomes the 4, the 5x becomes the 5x, the plus is the plus, the equals minus 5. All that's the same. The only difference is I went from 2 times x plus 3 to 2x plus 6. And sweet, most of you guys know that's called the distributive property. Distributive property of multiplication. So DPE, distributive property of equality. Means that once you distribute something, it's still the same. So now I go from here, and you can see that the only difference is I did actual 6 minus 5. And for our class and our things, we're going to justify all of those things using this word. I guess it's not addition property equality because I'm not doing it to both sides. We're going to say that it is, for us, simplify. So I'm going to simplify that expression. Good deal? This next step right now, you can see that I go from 2x plus 1 to, there's still the same 2x plus 1, but now I've got a minus 2x on this side, and I got a minus 2x on that side. So I did both of those to both sides of the equation. Well, what I'm doing then is subtraction property of equality, and that states that as long as I subtract something from one side of an equation and I do it to the other side of the equation will still be equal. And then of course you can see here 2x minus 2x leaves me with a 1. So from going from that line to this line, and from this right here to that line right there, all I've done is simplify. I've combined like terms, if you want to think of it that way, but again, we're going to use justification to simplify right now. Then you're going to see that I subtracted 4 from both sides of the equation. I did minus 4 on both sides of the equation. That's to move that 4 over there. So that's subtraction property of equality again. Subtraction property of equality. And then one more time, I did the work, I did the math, so I'm simplifying. And that's what we're going to try and justify down. We're going to write that step down. And now here, just like you normally would, you're trying to get the x by itself. So you can see that from this step right here to this step right here, I've divided both sides of that equation by 3. So that's division property equality. Again, just the justification as to why we're able to do what we're doing. one more time, then I simplified. And this one basically shows if -1 is equal to x, then x is equal to -1. And I kind of switched their places on that, okay? So we're going to have 3 different properties as we go through some things called reflexive, symmetric, and transitive. And we are going to, hold up, we're going to talk about those ones, okay? So the reflexive property says, and the symmetric property says, in fact, let me go ahead and let me put these out on a different piece of paper right now for you guys so that you can have a little bit more space on this, okay? So reflexive, symmetric, and transitive properties of equality looks just like this. So is that a good camera angle? Reflexive property basically says that anything's equal to itself. So that A equals A, or segment AB is equal to segment AB. You're like, that's kind of dumb. Why do we need to know that? As we go further and further into these proofs, I promise you that's going to be a very essential part of some of the proofs that we're going to be doing. But basically says that everything is equal to itself. Now, the symmetric, kind of like symmetrical, symmetric property says that if A is equal to B, that's our if part, if A is equal to B, then B is equal to A. So if 4 is equal to 8 over 2, then 8 over 2 must be equal to 4, right? So that's what symmetric says. If x is equal to 5, right, like we had on this last one, x is equal to 5, then 5 also equals x. That's the symmetric property. It can switch their places. And then the one that's really, really important for a lot of stuff in math, that's called the transitive property of equality. And it says this, that if A is equal to B and B is equal to C, then, and I think you guys could probably get this right, then if this is true, then we know that A must be equal to C. Okay, so the transitive property says if, basically it says if B is equal to 2 different things, then those 2 things must be equal. So kind of like if Anna is the same age as Bob, and Bob is the same age as Cindy, then Anna and Cindy must be the same age, okay? Transitive property of equality. And that's what we're going to kind of go through, is we're going to take a look at all of these properties, reflexive, symmetric, transitive. We're going to look at the addition property, subtraction property, multiplication property, all those ones. This one right here, substitution property of equality, we've already used that repeatedly in this class. If A is equal to B, then A can be substituted for B, or B can for A in any equation or expression. For instance, we solve, let's say this problem right here, and I got a little right angle, and I get this is 3x plus 10, something like that. And over here I got another angle that says that this is x minus 5, and I want to know how big, I want to know how big this angle is down here at the bottom. Well, the first thing I would do right now, right, is I would be able to solve for x. So I can write 3x plus 10 equals 90 degrees. And I know that that equals 90 degrees because that's a right angle. And by definition, a right angle is equal to 90 degrees. I can put all those things out and justify them. So now I've got 3x is equal to 80, and x is equal to 80 thirds. If I want to take that and change it into a decimal, I can throw that into my calculator and do 80 divided by 3, enter, and I get 26.6 repeating. So I know that x is equal to 26.6 repeating. And now I can take that, and I can take that number, 26.6 repeating, and plug it right into there. And why am I legally allowed to do that? Because of something called the substitution property of equality. Okay? So that's kind of what we're going to be dealing with right now. It's still just doing the same sort of algebra that you guys have been doing over the course of the last couple of years, except to build us into what we're going to do with geometry in terms of being able to justify and reason out everything that we do. We're going to try to do this. We're going to try and give you an equation, and we're going to try and solve that equation, and we're going to try and make a justification for every step along the way that makes that work. Now here's the deal. Just like if I was at the school right here, so at the school, and I wanted to go to Myers, which is way over here, Myers, which is way over there, I could possibly get there several different ways. Like I could leave out the side of the school, get onto 34th Street, come down here to DE, take that to 32nd Street, all the way down to G Avenue, and take G Avenue all the way over to Myers. I could also go out the front of the school, hop on M89, and that would take me all the way to Myers. Now this isn't drawn to scale. My point is simply this. I can get from point A to B flying straight, but I can't take roads straight like that. But I could also go several different directions. So as long as my end up is here, and I didn't go off-roading any place, I didn't do anything illegal, it doesn't matter which way I go, okay? So it could be that two different people do a proof different ways where their steps are not identical, but they both work. As long as everything they say works and is legal, it's good. Just like if you went into a court of law, there might be one lawyer here, call it lawyer A, and lawyer B, where lawyer A tries to defend it a certain way and lawyer B goes a completely different way about it, but both of them end up acquitting the person that they're representing. Again, as long as they can prove their innocence, whether or not they do it this way or do it this way, it's all good. What they can't do, or what they're not supposed to do, which unfortunately our media, sorry, little tiny rant right now, our media right now has some issues with it, okay? And I'm not saying one side's better than the other in any way, shape, or form for you guys, but we got to be careful. We got to be careful about what people actually say, because unfortunately, too many times, just like with everything in relationships, some people have agendas that they want to see go one way or another way. So the best thing that I can say for you all the times is really educate and question. Okay? So educate yourself, know as much about the information as you can, and question it. Don't just assume, don't accept facts for it. That's this geometry class is like perfect for that. We want to make sure that we know facts. Okay? So hopefully this stuff helped, and the stuff that we're going to do in class is going to help, and that was a great start for it. So again, these are going to be algebra proofs, just justifying from step to step to step which ones they are, and you'll be able to practice them in the 2-4 online homework. Okay? We'll talk to you guys. Put it sideways. We'll talk to you guys later. Take care. Stay up on top of your stuff. If you guys have questions, come see me.